Jai Hind to all. Myself, Dr. Yogendra Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Today, I am going to deliver a very important lecture on computer organization and architecture, cache mapping. Before going to explain what is the cache mapping, first we are discuss about the what is the cache, what is the different type of the cache, and what is the memory hierarchy, and what is the role of the cache in memory hierarchy. Now, what is the cache? Cache is a very small memory, fast storage to improve the average access time to solve the memory. Cache memory is very fast, is small, and to reduce the access time of the CPU to the main memory, so that cache memory are designed. Simply cache memory are designed between the, now if this is the CPU, this is the main memory, and in between cache memory are designed. Now, this is the basic architecture of the cache memory are designed to exploit the special and temporary locality of the reference. That is the another important of the cache memory. In computer architecture, almost everything is in cache. It means when CPU want to access the data, then first CPU access the cache. If data is found, then computational process is processed. If data is not found, then data are transferred from main memory into the cache memory, then cache memory into the cache memory, into the CPU. Now, if we discuss about the what is the memory hierarchy, then register is a cache on the variable. The fastest memory is known as the register or the flip-flop. Then the first level of the cache on second level of, there are two type of the cache, L1 cache and L2 cache. The L1 cache are designed into a CPU, and the L2 cache are the separate are inbuilt of, on the CPU. Then memory, that is the main memory. Then secondary memory here. Here is a secondary memory are designed. So these are the some memory hierarchy concept. The second level of the cache, that is the L2 cache, and the TLB, and this one. Now we see if the data is available on the cache, no problem, that is known as the cache hit. If data is not available on the cache, then the data are transfer or data are mapped from main memory to the cache memory, and then cache memory to the CPU. So it means there are the different type of the methodology by which data are transferred from main memory to the cache memory. That different type of the technology is known as the cache mapping. They are the cache mapping. Cache mapping is a technique device that main memory block will be placed into the cache memory. It means these main memory data of the main memory are mapped into a cache memory. That technique is known as the cache memory. It will found later using the address in this format. The address of the data are represent, that is tag, index and offset field into a cache memory. But if the data are present into a main memory, then address are only the offset field and the index. In computer architecture, there are the three type of the mapping schema used. First one is the direct mapping, that is the most important mapping, and every year asks the numerical question on the direct mapping. Fully associate mapping, it is also the important, and the set associate mapping is also the important type of the mapping. But direct mapping, a lot of numerical questions asked into the university examination and GATE examination also. So, we are going to discuss the basic concept of the direct mapping. Now, first we take the very simple example. Suppose here in main memory total 32 number of blocks. In main memory 0 to 31, it means total 32 number of blocks. And in cache memory, cache memory 4 number of blocks. The number of blocks in main memory is known as the block number. The number of block into the main memory, that is known as the block number, and the number of block in the cache is known as the line number. And in each block into the main memory 4 words are contained, that is 0, 1, 2, 3, 4, 5, 6, 7, and total 32 number of the size of the main memory 32, and in each block 4 words are contained. It means how many the size of the main memory? The size of the main memory, it means 4 into 32, that is known as the 128. And if we consider the size of each word is 1 byte, then the size of the main memory is 128 byte. Now, here is what is the last word, that is 127, 126, 125 and 124. In each block 4 words are contained and the size of each word is 1 byte, then the size of main memory is known as the 120 byte. So, what is the meaning of 120 byte? What is the physical address generated by the CPU? That is 128. Now, 128 means 2 to power, I think 7. 2 to power 7. So, 2 to power 7, it means 7 bit require to represent the main memory. Then, and what is the number of the block? The format of the main memory is known as the block offset and block number. So, how many block number are available into the main memory? That is 32. It means it requires the 5, and in each block contain the 4 word, and what is the minimum bit required to represent the 4 bit, that is 2 bit, and 32 number of block are represented by the 5 bit. Now, it means that is the physical address are represented in this format into the main memory. If these block, that is block B0, B1, B2, B3, B4, B5 and here is a B31 number of blocks. This is the main architecture of the main memory. This block can be accumulated into a cache memory. Now, here is a line number 0, line number 1, line number 2 and line number 3. Now, in direct mapping, B0 are accumulate in L0. B1 are accumulate in B1 and B2 are accumulate in B2 and B3 are accumulate in line number L3. Okay. Now, what is the size of the cache? The size of the cache, if we can calculate, that is very simple. What is the size of the cache? What is the size of the cache? What is the size of this? 4 byte. Size of this 4 byte. Size of this also a 4 byte. Size of this is also a 4 byte. And the total number of block is a 4 lines. It means 16 byte. This is the cache size. Then how can we this number of block can be accumulated into the cache? Now B4 block can be accumulated in this block. Now B5 can be accumulated this block, B6 and B7. Now this is the method is direct mapping are performed. Similarly, B8, B12, B16, it means the line number L0 can accumulate 8 number of blocks. Similarly, L2 can also accumulate 8 number of blocks, L3 can also accumulate 8 number of blocks, and L1 is also accumulate 8 number of the blocks. But at only one time it can accumulate a single blocks. Either B0 are present into the cache, either B4 are the present, either B8 or B12 or B16. At one time only one block of the main memory are accumulate into a cache memory. Now total size is 7 bit. Now 7 bit if cache, then 2 bit is fixed, because in B0 there is a forward, that is 0, 1, 2 and 3, and the 2 bit is required. Now second one is known as the line number, that is also known as the index. So how many line number are available into the cache? That is also known as the 4, it means 2 bit required. And how many total bit of this physical address? 7, it means tag bit is 7. So this is the method to represent the physical address into a logical address. And this is the address of the cache. Now this is the previous one address is known as the address of the main memory. Now this is the address of the cache memory. Now this is the method by which the direct mapping can be performed. So this is the very simple example. We take the another example which is asked into the university examination. Now this problem is also very important problem asked into a university examination. Now in a cache line using this simple formula, cache line block number. Now this is the method which is I already discussed here. In each now we take the very simple example that question is asked in the university examination. Now in direct mapping, cache size 32 KB with block size 32 bytes. Now suppose this is the cache. What is the cache size? 32 bytes. What is the 32 bytes? 2 to power 5, that is 32, 2 to power 10. Now it means 2 to power 15. The total cache size is this, and in each block 32 bytes. 32 bytes means 32 KB, and the block size is 32 bytes. 32 means 2 to power 5. Now the number of lines in cache, that is 2 to power 15 upon 2 to power 5, it means 2 to power 10. In cache, total number of line, that is 1 2 to power 10, it means 0 1 0 23, and the size of each block is 32 byte. 32 bytes. Okay, this is the about the this one about the size of the main memory. The size of the main memory is 32-bit address. The size of main memory, that is 32-bit, that is the main memory, and 32-bit are divided into the two parts. The first one is the block size, and the block size is 32 bytes. 32 bytes means 5 bit, that is the 5 bits. Now remaining bits, that is the I think 27 bit, that is known as the block number, and that is known as the block offset. This is the configuration about the main memory. What the question are asked, that is very simple. The number of bit required for cache index, this one is known as the cache index, and what is the size of the tag bit respectively. Now 32 bit, 5 bit is common, 22 bits are divided into the two parts. The first part is known as the line number, it is also known as the index, and the second part is known as the tag, it is known as the how many blocks of the main memory can accumulate into a cache memory in a single blocks. It means this physical address can be calculated, can be split into a logical address here. That is very simple. In GATE examination, this question is asked in 2 marks, but in university examination, it is a long questions. Now, what is the total size? 32 bits. Now, 5 bit is no changes. Now, here is a 10 bit, that is known as the line number. Here is a total 2 to power 10. This much line are available into a cache. Now, how many bit are remaining? 15, and how many total size is 32 bits. So, how many bits? 15, I think 17. Yes. So, now this is known as the tag bit, that is known as the index bit, or that is known as the block offset. That is very simple. How many the index? Index bit is 10 bit. What is the tag bit? Tag bit is 17. So, that is very simple question asked into the university examination. We move on to another important question that is based on the GATE examination. Now, this one you can pause 1 minute and then solve this question. Now, what is the size of the main memory? Size of the main memory is 4 GB. Now, what is the 4 GB? First, we discuss about the main memory. that is 4 GB. It means 2 to power 2 into 2 to power 30. Now this is known as the GB. Now, yes, now this is known as the 2 to power 32. 2 to power 32. That is the this is the relevant data according to main memory. What is the cache size? That is very simple, 1 MB. Now cache size, that is 1 MB. It means 2 to power 1 MB, 1 into 2 to power 20. That is again 2 to power 20. That is the size of the one. Now this one is the very important data. Block size is 4 KB. Now block size. Block size is 4 into 2 to power 2 into KB. It means 2 to power 10. It means 2 to power 12. Then how many number of blocks are available into a cache? Now number of blocks in first main memory, that is 2 to power 32. Now block divided by 2 to power 12, it means 2 to power 20. So I think we can draw the architecture of the main memory. Total number of blocks into the main memory, that is known as, here is a 2 to power 20, and the size of each block, that is known as the 4 KB. And if we calculate this size, total size is 4 GB. If we can understand this concept, then we can easily draw the physical address. Now what is the physical address? That is very simple. Physical address, here is a 12 and here is a 20, and our total size is 32. Now this one is known as the block number, this one is known as the block offset. Now word size is 1 byte. Block size and word size 1 byte. Now what is the question is asked? Physical address. Now this one is completed. What is the tag directory? Tag directory, that is very simple. Tag directory you easily can be calculate. Now this one again. Now this 20 bits are divided into the 2 part. Now what is the cache size? Cache size here is 1 MB, 2 to power 20, and the what is the number of lines available? It means 2 to power 20 and 2 to power, here is a 12. It means 2 to power 8. Now this one 8 bit here, and here is a 12 bit. Now this one is a, what is the tag? This one is a tag, this one is index, and this one is a block size. Now this one question asked in the GATE examination, that is very simple. We can calculate the tag side, index side, and block size, that is respect to the cache memory. This one this address is calculated with respect to the main memory. And some another important question we are discuss in the next lecture. Thank you.